SAS demonstration using random number functions. In the first part of this demonstration, I'm going to show you how to use the ranUni function. So I'm creating a data set called temp, and all I'm inputting into this data set is a variable called words, which is a character variable. And basically the data is just word 1 for observation 1, word 2 for observation 2, all the way to word 9 for observation 9. So that's the variable that I'm reading into this data set. And then I'm creating a new variable called ranVar, and I'm setting it equal to the ranUni of 0. So my seed is the clock time. And then I'm interested in just printing out our data. So what happens when we use this ranUni function to create a variable called ranVar? What do we see? So the function ranUni with a seed creates a number that is some number between the value of 0 and 1. When you use 0 as your seed, the clock time is used, and so every time we run this program, we're going to get a different list of random numbers. So let's run it again and see what the random number list looks like. So here notice that the variable ranVar has a totally different list of numbers than the previous time that we ran this program. We have a totally different list of numbers because every time that we run this program, we start with a different initial seed because we're using the clock time as the seed. If we use the same number every time in the seed, then we would always get the same list of random numbers. So let's change our seed here to 1, 2, 3, and we'll run that, and here is our list. If I run this code again, notice I get the same list again. So each time I run it, I get the same list. So let's go back and change it to 0, which is where SAS will use the clock time as the seed, and we'll get a different list of random numbers each time we run this program. So now we have a totally different list of random numbers. Now we're going to do something fun. We're going to sort our data set temp, and we're going to create an output data set called temp2, and we're going to sort it by the random variable. So basically what we are doing is we're sorting these 9 words, and they're going to appear now in a random order because we're sorting it by this variable ranVar, which was generated from the ranUni function. So here we have our words in a random order, word 1, word 5, word 3, because what we did was we sorted this data set by the variable ranVar. So it went with the smallest value of ranVar all the way to the largest value of ranVar. And then the words, when we printed out this data set, were randomly ordered. Now we can actually get a random sample of this data by asking SAS to keep only the first n observations in this example. So let's say we're interested in taking a random sample of 5 observations from this data set of 9 observations. So here we're creating a data set called subset. We're bringing in this new randomly ordered data set temp2, and we're making use of that automatic variable _n_, which is basically a counter. It's a variable that tells you what observation is being processed in your SAS data set. And we're interested in only those observations that were less than or equal to 5. So the first 5 observations that were processed in the data step. And because temp2 is now in a random order, we're picking the first 5 observations, and they will be a random sampling of our 9 observations or words. So here we have the final subset of 5 observations. So we have randomly selected 5 observations from our 9 observations. So we selected an observation that was word 1, an observation that was word 5, an observation that was word 3, an observation that was word 7, and word 2. So remember, each of these observations is identified by the variable word. So this is just an interesting way of understanding how the RAND-UNI function is used to generate random numbers, and just a simple way of how we could take a random sample from this group of observations that were identified by the variable word1 all the way to word 9. Let's say I was interested in randomly assigning patients to study groups. So I wanted to generate a list of patient assignments that, for example, I might be giving to a pharmacist. And so let's say we're planning on having 30 subjects participate in our study, and we want to randomize them to either a control or a treatment. So first of all, what I'm doing is I'm creating a format, group format, where 0 equals control and 1 equals treatment. And then I am creating a data set called assign. And this is something different that we haven't seen before. I'm not doing any kind of input of data. I'm actually using a do loop to generate my data set. And so I'm saying do subj equals 1 to 30. If RAND-UNI 1, 2, 3, so that's our seed, is less than or equal to 0.5. And remember, our function generates a number randomly between 0 and 1. So if it's less than or equal to 0.5, then I'm going to say group equals 0. Otherwise, group equals 1. So if it's greater than 0.5, then it's going to be group equals 1. And within my do loop, I'm then going to output that observation. So when subject equals 1, I'm going to output an observation that has this index variable subj on the data set, as well as a variable group. So here I'm going to print out this data set called assign, and I'm going to format group with the group format. And I'm also going to look at a frequency of group. So let's see what this data set assign looks like. So first of all, it looks like we have a data set of 30. There were 13 controls and 17 treatment. So in our data step, we had randomized 13 subjects to the control group and 17 subjects to the treatment group. And here is a list of all our subjects. So these subjects were randomly assigned to a treatment or a control group. And again, because we had this do loop, the variable subject or subj was put on our data set because it was the indexing variable. Now there's a problem here, because notice we have 13 controls and 17 patients who were randomized to the treatment group. What if we wanted to be certain that 15 patients were randomized to the control group and 15 patients were randomized to the treatment group? Well, the problem is that we can't guarantee that with our program, because again, we're randomly generating numbers between 0 and 1. And so if we did this 30 times, we're not guaranteed that exactly 15 are going to be less than or equal to 0.5, and therefore would be randomized to group equals 0. So how can we get around this problem so that we randomly assign subjects to study groups of equal size? To randomly assign subjects to study groups of equal size, we are going to make use of the SAS utility procrank. So we're going to start with the same code where we're generating 30 subjects and we're giving each subject a random number between 0 and 1. And this variable is called group. So here, group is going to equal a random number between 0 and 1. And then we're going to bring this data set into procrank. So we're bringing in the data random. And we're creating an output data set called split. And we want exactly 2 groups. So what procrank is going to do is it's going to create a variable study group, which is going to take on the value of 0 or 1 based on whether the value is less than or equal or greater than the median of group. So our variable group is now a continuous variable that ranges between 0 and 1. And then I'm going to go ahead and print out this new variable that we've created from procrank and attach the format group format, and then I'm going to print out the whole data set that we've just created called split. So notice here that we now have two groups that are of exactly equal size. We have 15 controls and 15 patients that would be randomized to treatment. And here is a printout. And so if I were to give this list to a pharmacist, that pharmacist would know, okay, if the first patient was enrolled on the study, that patient would get the treatment. If a second patient was enrolled on a given study, that particular patient would be randomized to the control group, and so forth. So what we've basically done is produced a randomization list that could be used by whoever is doing the randomization for a particular study. Most of the time when I generate these assignment lists, I would be giving it to a pharmacist who's going to be labeling the particular medication for whether it's a treatment medication or a control medication. I also want to point out that because we are using this seed 1, 2, 3, we will always get the same order to our list every time I run this program. Because if you use the exact same seed, it will generate the exact same list of random numbers. If I used a seed of 0, then every time I ran this program, I would get a different randomization list. This concludes the SAS demonstration using random number functions.